Today's main topic is still kinematic, and its subtopic will be freefall. Please like, share, comment, and subscribe to this channel. We worked on kinematic previously, but right now we're going to be working on another subtopic in kinematic, that is freefall. Now follow me, let's dive in and continue. Freefall. Freefall is when an object falls experiencing only acceleration due to gravity. So the simplest real-life example of motion under a pretty constant acceleration is the motion of an object in the gravitational field near the surface of the earth, and ignoring any effects due to air. So when an object, this is the surface of the earth, this is the earth, let's assume this is the earth of the earth, and an object here falls within the surface of the earth, of this gravitational field, surface of the earth. That's what this is talking about. If an object falls within this gravitational field of the surface of the earth, we're not talking about a plane. We're just talking about like a ball falling from a top view, from the top of the stairs down, like because that is still within the gravitational field of the surface of the earth. And when the fall happens, there's not an air effect. There's no effect on the fall. The fall object just falls freely. That's when we categorize that as free fall. With this effect, an object just falls freely. So when an object falls freely in this category, it falls experiencing only acceleration due to gravity. And the gravitational acceleration has a constant magnitude of this 9.8 meters per second. And this quantity of 9.8 meters per second is denoted with G, as G. But for the sake of this AP physics, you can use G is equals to 10 meters per second square. That can be used. This will help for simple calculations so that you don't, when you're having these simple calculations, you can just use that. Since the gravitational force is talking about the gravitational accelerator vector, and its gravitational accelerator vector is pointed downwards because the fall is going down. The body is going down this way. For the sake of keeping this consistent throughout this AP physics, we will set gravity G as negative 10 meters per second. So gravity G of the free fall will be minus 10 meters per second square because of the free fall that goes down that way. Let's look at some example and see how we can have these calculations down. So looking at this example, a rock is dropped from a cliff of 80 meters above ground. How long does it take to reach the ground? So now, a rock, let's assume this is the rock here, and this is the cliff. It's dropped from the cliff, and the cliff is 8 meters high. The cliff is 8 meters high, 80 meters high, and here's a rock. So we want to know, how long does it take to reach the ground? Does this rock take to reach, and this is the ground level? How long does it take to reach this ground level? So looking at the big 5, we'll use the third number that says what y is equals to yo plus vo t plus half at squared. So in this case, our y0 is 0. Y0 is equals to 0. And if there's no velocity here, so the VO is also equals to 0. So if y is equals to 0, therefore now if y O is equals to 0, that is 0 plus, since VO is 0, 0 times t is 0 plus half AT square, half AT square. So which is equal to, y is just equals to half AT square. Now, the A it stands as a free fall, which is -10. So the A is a free fall, that is the acceleration due to gravity, that is -10. Therefore, y will be equals to half minus 10 t square. They were looking for how long. When you hear how long, we know that is time, right? So now in calculate, we're looking for the time. So t, for us to get t, will be equals to this one. This 2 goes up here. This 2 crosses up here, so it will be 2y over -10 square. Since it's t square, we'll find the square root of the value, which is 2. Y is the height, the final height, that is 10. Sorry, that is 80. Y is 80 over -10 in square root of the whole value. By the time we calculate it, the value we get, y will be -80. The value we will get to be 4 seconds. 4 seconds is the answer. Okay. There's the value for this. Okay, let's look at another example. So it will take 4 seconds for it to get to the surface of the ground, right? Okay, let's look at another example. 1 second after throwing straight down, an object is falling with a speed of 20 meters per second. How far will it be falling in 2 seconds later? So here we have 1 second after being thrown straight down, 1 second after being thrown straight down, an object is falling within a speed of 20 meters per second. How far will it fall in 2 seconds? So looking at this, we are looking for how far distance, how far will it fall in 2 seconds. That's we're looking for the final velocity in this thing. So we're going to pick the big 5, number 2, that says v as is the final velocity is equals to initial velocity plus acceleration times time. So when initial velocity is what final velocity is what we are looking for. But here we have VO is, it falls 20 meters per second. So VO is -20 meters per second. And the acceleration A is equals to, that's free fall automatically, that is 10 meters per second square. And the time taken takes 2 seconds. 2 seconds. Now for us to find the V would be -20 plus -10 times 2 times 2, which will be -20 minus -20, which equals to V -40 meters per second. Right. So that is the final velocity, will be 40 meters per second. It takes it 40 meters per second for it to fall 2 seconds later. All right. Okay. So let's look at one more example. So this is another example of a free fall. Says if an object is thrown straight upwards with an initial velocity of 20 meters per second, and it takes 3 seconds to strike the ground. From what height was the object thrown? So in this case, we're looking for the height. What height was the object thrown? We'll apply the big 5 number 3 that says y height is equals to initial height plus initial velocity times time plus half half 80 square. So in this case, our final velocity we don't know, right? So the final velocity is defined as 0 because it's thrown upwards. So it's 0. There's no final velocity here, so it's 0, right? Because it's just thrown upwards. It doesn't say when it's landed to the ground, so there's no final velocity defined. Then the initial velocity here. So the initial velocity here is what we are looking for. We don't know what the initial velocity here is. So the initial height, we don't know what it is. The initial velocity now is 8, so at 8 meters per second, and it takes 3 seconds. That is the time. Time is 3 plus half. Gravity is -10, free fall. Then t square is 3 square. So for us to get this value, it's equals to YO. Let me add it up. 8 times 3 is 24. This is 9 times 10. That will be 90. Divided by 2, that's 45. So 24 plus 9 times 10, that's 90, plus, so not plus, negative minus 45. That will be equals to YO minus 21. So therefore, YO is equals to y up is equals to 21 meters. Okay, so y0 now is equals to 21 meters. All right, so that's how we calculate for free fall. Let me know if you have any question. That's the end of today's video. Please don't forget to like, share, comment, and subscribe. The more you come back to my videos and comment on it, encourage me to make more videos. Thank you. I'll see you in the next video. Bye.